All right, guys. So today we are solving the problem 2 sum. Let's see. Given an array of integers and a target, return the indices of the two numbers that add up to the target. Exactly one solution exists, and you may not reuse an element. This is the most infamous question. This is lead code #1, the first question everyone faces. So let's see how to solve this problem. So what does it say? We have a given array and a target. So we basically run two for loops and we just add them up to and check if it sums up to the target, and then just return the indexes of them. Let's see the brute force in action. All right, let's solve this one. So what do we have? We have a given uh, and a target. Then we write a for loop for I, which starts from 0, goes till n negative 2. Then we have a for loop. We have a second for loop, j, which is I plus 1. It will start from the next index, right? Which is from 1 and goes till n negative 1. Looks good because n negative 1 is this and n negative 2 is this, right? Now, if ARR of I plus ARR of j is equals to target, then we just return the I and the j. If we don't have anything, we return none. Let's evaluate this. Great, looks good. Let's try to solve in the brute force style. We have this in JavaScript. So what we had a target, we had nums, right? So let's start off with a for loop for let I is equal to 1, I mean 0, I less than is gonna be less than nums dot target, sorry, nums dot length. Why did I nums dot target? I'm hallucinating. Negative 1 I plus plus, right? Then we have a j. J is equals to I plus 1. J is less than, is going to be nums dot length, j plus plus. Now we check if nums of, like since the ARR is nums over here, we just check nums of I plus nums of j is equals to the target. Then we just return the array of I and j. It expects it in an array, right? There is exactly one solution. You may not use the same element twice. Yes, so we are expecting the output in an array, which is I and j. If nothing, we just return null. Looks good. This, oh, we need to log in. Shit. Let me just log in real quick. Okay, looks good. Let's try to submit this, but this should, uh, no, this actually went through, but this should have caused some sort of issues, but it did not. I thought it's gonna create some problem regarding runtime error. It will take a lot of time. Anyways, let's move on to the optimized version, which is the hash map. Hash maps have a lookup time of O of 1, like it's instant lookup time. So what do we have? We have a given array, a target, and an hash map called scene, inside which we will store the stuffs as like we'll store the value followed by its index. So it's written like that. So now it says we are going to run a for loop I, which runs up until n minus 1. Then we need a variable called need, inside which we will save the difference between target and the current value of like inside the array. So we'll be needing that. If the need is inside the scene hash map, then we just return the index of that and the current I. Else we put the value of the current value in the array as the index inside the hash map. So let's see this in action. All right, let's try to write this now. So we'll have a given array, a target, and a hash map called scene, right? Which is a hash map. Looks good. Which will have a value followed by index. We'll store it in this fashion. Then we run a for loop so that we can check the whole array and try to iterate it. For I, for loop of I, which starts from 0, goes till n negative 1. Then we need a variable called scene, inside which we will save the difference between the target and the current value. So what's the target over here? It's not actually mentioned. Let's say the target is 10, then we just go for 10 minus 3 and see if 7 is inside this array or not. So we just do that kind of thing. ARR of I. If seen in not seen, it will be called needed. If needed in seen, we return we need to return an array of needed of seen. It's actually gonna be the opposite. Seen of needed followed by the I, the current I that we are looking for. Else we need to do seen of needed actually is going to be seen of ARR of I and put the value of I inside it, right? Because if we don't find it, we need to insert the value followed by the index inside the hash map, which is seen. Else the value is found. So we just take the needed, which is the value, and the index, the current index, and we just put into that. And then we go. If there is nothing, we just return none. Let's execute this. This should be good to go, right? Let's try to now solve this in the optimized version. What do you say? We need scene, right? So it's gonna be a hash map. Let scene. Actually, I forgot the methods. Probably I'll need to look them up. Let I equals to 0, I less than nums dot length, I plus plus, right? If um, then we will need let need equals to target minus nums of I, right? We'll be just needing the current. If need in, like, is this even a syntax? I don't know. I have to check that later on. I I think it's gonna be scene dot has like that, but we'll check it out. If need in scene, then we just return an array of scene of need comma I. Else we need to put scene of arr of I. It's not gonna be arr, it's gonna be nums of I equals to I. If we have nothing, we just return null. If this syntax is correct, this should run properly now. Okay, so yeah, this is the thing in JavaScript. It's just my confusion. Let's submit this. All right, guys, thank you for watching. This was 2Sum.